name's Andy Tidy and welcome back to another edition of Canal Hunter. At the end of my last episode, I was exploring the line of the Ogley Locks, and I'd come all the way down from Brownhills to Lichfield, and I'd come to a halt at the Sandfields Pumping Station, and then coronavirus hit us and the rest is history. Well, sadly coronavirus is still with us, but I've come to learn the history of a different epidemic set probably 150 years ago, and the catalyst for the solving of that particular case lies here behind me at Sandfields Pumping Station. Over the summer, David Moore, the president of the Restoration Trust, got in touch with me and said, Andy, there is so much more to this old building and its contents, so why don't you come down and have a proper look? Well, here I am standing bang on the line of the original Ogley Lock section outside the pumping station, and we're going to go inside and have a look at what this old building contains.
Yeah.
Right, I'd like to introduce you to introduce yourself.
Okay, my name is David Moore. I'm chairman of the Lichfield Waterworks Trust. Part of my job here is to actually restore this redundant Victorian waterworks that was actually, by coincidence, built in quite strange times when there was a cholera pandemic.
Is that right?
Yeah, absolutely. Yeah.
How topical? Because of course, when I finished my last series or the last episodes on Canal Hunter, I actually had got exactly to here to the waterworks, and well, it's just quite fascinating to be given an invite back in and have a look around what's inside this amazing building. I just thought it was a rather utilitarian railway-like building, but actually there's so much more to it. So do you want to tell us why it's here?
Yes, certainly. Okay, so in the middle of the 19th century,
Yeah.
a pandemic hit Britain in 1831. Cholera. It came off the continent. We knew it was coming, like today's pandemic. We knew it was coming, and there was nothing we could do.
Yeah.
We didn't understand the cause of the disease. We didn't understand the cure. Ultimately, when cholera arrived in the Black Country, it arrived about the 4th of August. It wiped out, about 2,500 people in the space of 6 weeks.
What sort of percentage of the population is that?
Well, that's probably about 10% of the population.
Okay, it's bad.
It's bad, and it's a nasty disease.
Mm.
I mean, cholera, you catch it within 4 hours, you can die.
Right.
And it's a filth disease.
Mm.
You get severe stomach pains, your body turns blue, you get tremendous diarrhea, and like I say, you die very quickly. It's a very nasty disease. And the problems, of course, was there were so many people dying so quickly. Several people in the same households would become ill and die within days. That the bodies were piled up in the streets. People were scared to touch the bodies.
Yeah.
They didn't know what to do. The graveyards were being shut down, and it was people were panic-stricken, literally. The resolution actually came in London by John Snow, the physician.
You're right.
So John Snow himself, he made a link between cholera and clean water. Once John Snow had made that link, it then sort of, as in today's pandemic really, once you understood the spread of the contagion and what was causing the spread, then you can put measures in to deal with this. And in the case of cholera, it was as simple as clean water. Now, I say simple, there were a lot of factors involved, which is, first of all, the Black Country,
Yeah.
due to its industrialisation, had a shortage of clean water anyway. So the deep mining was draining the wells out, the industrial processes themselves was polluting the water,
Yeah.
and the sheer population that was moving into the Black Country was sort of using up any remaining water. In fact, some of the canal companies were complaining that people were drinking the water from the canals to such a degree
Yeah.
that you couldn't get barges down the cut.
Right.
So the Black Country got this real problem with water.
Yeah.
Now, the engineers, they knew that there was clean water over in Lichfield.
Yeah.
Lichfield wasn't an industrialised town. It was pretty clean. The problem they'd got was, how do you shift that sort of volume of water from Lichfield, 11 miles away, back to the Black Country, which was 400 feet higher?
Yeah.
it was it was a pretty monumental journey challenge that they got. So eventually they came up and they built this waterworks. It was a vast investment. It was probably the equivalent of about £40 million in today's money.
Wow.
And this is just one area.
And are these people trying to make money or what?
Well, funny enough, no. I mean, the people who built it had already sort of made money, and it was more of a sort of philanthropic endeavour.
Yeah.
And they actually sort of knew that they might just about break even, but
Right.
they certainly weren't going to become rich doing it. It was sort of part of their trying to give a little bit back to society.
Yeah.
And a lot of the money was sort of raised by small £5 investments,
Right.
which they didn't quite make sufficient money, but it was sufficient to get the waterworks set up.
Okay.
And that involved modifying both the lakes in Lichfield. They also had to build a 3/4 mile tunnel. They had to build this building and an 11-mile pipeline to Lichfield, plus various parts of infrastructure.
So those
And
lakes you were talking about, is that the one in front of the cathedral?
That's right. So Minsterpool is the
Yeah.
first lake. That captures the water from the Limonsey Brook. You've then got Stokepool behind that.
Right.
That sort of then takes a runoff from Minsterpool to Stokepool. The water's then transported back under Minsterpool and then down a 3/4 mile tunnel, which sort of ends up 80 feet below where we're standing now.
And what sort of volumes are you talking about?
The volumes it was capable of delivering was about 4.5 million gallons a day.
Right.
So Lemonsey Brook could probably supply about 1.5 million to 2 million gallons of
Right.
water. And then there was a fair bit of percolation water
Okay.
that flowed into the tunnel as well.
Yeah.
And that sort of then made up the volume. And then what you needed then was some enormous machinery to shift this water up its 80 feet and away to the back country.
Right.
Yeah.
Okay. And, well, this wasn't... this one here that we see
Yeah.
is not the first.
That's right, yeah. So what happened is there were 3 Bolton watt beam engines built in the adjacent building.
Yeah.
They started operating in about 1854 and started pumping fresh water. The scheme was so successful that there was calls for more water very, very quickly. So they added this 4th engine. Now this 4th engine is a monster.
Yeah.
It's probably one of the 4th largest steam engine ever built on the planet.
Right.
And it's an absolute monster, this thing. It can gulp a sort of ton of water in one go.
Wow. And how many how fast does it take
and it
to
would
go?
do that between 6 and 8 times a minute, and
Wow.
it could take a gulp about every 1.5 seconds.
Wow.
So this thing was capable of pumping probably about 2.5 billion gallons every single day. So if you place that in the context of a canal, you could fill half a mile of canal in a day with this engine.
Wow.
It would empty the lake in Lichfield in a day.
Yeah.
It was capable of doing that. And the idea is they sort of relied on both the percolation water and the water flowing in through the Lemonsey Brook. Yeah. There was a term of 21 people had to operate all this.
Right.
So it was 3 shifts of 7 people for 7 days a week, and it was sort of non-stop. So although the engine itself sort of tended to run automatically,
Yeah.
there had to be a group of people who were stoking the boilers, keeping the engine clean, keeping it all oiled, and generally sort of watching to make sure it ran okay.
Right.
One of the problems with these giant engines is if they do run away, it can cause a catastrophic failure.
Yeah. Yeah.
Absolutely.
I seem to remember hearing that there was a tunnel that they built, an extra tunnel going out to the north.
That's right, yeah. So the Victorians, in their ingenuity, they were pretty aware that once they got this scheme up and running, the demand for water would rise. So the first tunnel they built it probably about 60 feet deeper than it needed to be built.
Right.
That enabled them, 18 years later, to extend the stream northwards to then capture more water.
Right.
And by putting the tunnel deeper, they were able to extend it right the way north to Seedy Mill.
Right.
And that then picks up the little brook at Seedy Mill and the lake at Seedy Mill and brings water 3.5 miles up to here.
Yeah. Fascinating that it's all sitting under Lichfield still.
And it's right. I mean, one of the things we said about this was this is Lichfield's best kept secret.
Yeah.
Because you've got this very sort of innocent looking building. One of the things I say about this building is its familiarity. The curiosity is eroded away by the familiarity in the landscape.
Yes.
It just sits there. Nobody actually thinks what it's did.
Yeah.
But it was part of a huge infrastructure, and it saved the Black Country.
Yeah, it's incredible.
Within 20 years of this building coming online, cholera became a thing of the past in Britain.
It's quite incredible.
And interestingly enough, it wasn't until 30 years later that they eventually identified the cholera bacteria.
Right.
So it was all done theoretically by John Snow. Yeah.
It's very timely to come and have a look at it.
It is. Yeah. Have a look round, yeah.
Yeah. What we're going to do is we're going to have a look around the building, and I'll show you lots of cut-ins of the bits of machinery. So this enormous cathedral to pumping engines has just sat here in mothballs for years.
That's right, yeah. So this original section, it became more or less redundant in 1927. The reason for that redundancy actually was not that they didn't want water, it was that the demands for cleaner water were made, so they had to build a filter house next door.
Right.
Now, to make the filters operate properly, this engine couldn't then meet the sort of differential demands of the filter. So this was put into mothballs in 1927, and the engines next door were replaced by engines that could operate the filter house.
Right.
And so this has sort of sat here as a museum since 1927.
Wow, 90 years.
90 years, that's right, in a state of
It's
preservation.
a small miracle that it's still it's not
yeah.
been scrapped.
Yeah, that's right, yeah, absolutely. I mean, there was certainly talk about scrapping it, you know, but it's heritage value, of course. Because it's quite unique. I mean, this is not an off-the-shelf engine. It was it was built in Tipton by a company called Jonah and George Davis. It was built specifically for this job only,
So
this job alone. Yeah.
Can you imagine bringing that beam in here? I don't know if they did it.
Well, it's 20 tons of it, and the stories are that it was probably bought on horse and cart.
Yeah.
And certainly, when if you look at some of the photographs in Tipton where they were moving the Titanic anchor around recently, so it was all built hand cut and pulled in parts and pulled in through the windows and assembled by hand labour.
Now, all the viewers know that I'm a bit of a canal nut.
Yes.
And the old line of the canal came right past
It
here.
did. Yeah.
But I don't think it supplied coal to the site. What was the connection with the canal?
So the connection with the Cal is it wanted the canal water.
Right.
So the engine operates and it needs a supply of cold water to cool the condenser down. So the deal was with John McLean, who built it, was we will give you 1 million gallons of water per year if we can sort of warm up some of your water and give it you back warm.
Fair enough.
It was a reasonable deal.
Yeah. I feel we really are in the bowels of the ship down here.
Certainly are. So below us, it extends about 80 feet down, and there's a sort of lift pump below that. The engine pulled the water up 80 feet. It took a ton of water every gulp, brought it into this force pump. Then this force pump forced it away up to Warsaw.
So this is the final exit point for the water going out.
It is indeed, yeah.
Well, the main outlet is just behind that.
That's right.
Sticking up bit.
Yeah, that's right.
Okay. And the canal connection, I think, is this section over here. Is this the condenser?
That's right. So this is the condenser, and this obviously called the steam now from the engine. It was, thermal efficiency, but it's actually used the water from the canal. And what would happen is the canal water would run in under gravity, and then they were obliged to give the canal people their water back. So these two pumps above our heads were installed, and it was those that pumped the water back into the canal. Okay, so this is the engine's main counterbalance. This is the actual pumping end of the engine. What would happen is this counterbalance was filled with about 20 tons of scrap iron, and the steam engine itself would lift the counterbalance up. This would lift the column of water up the 80 feet from the well below. The valves though would then shut, and as the counterbalance came down, this then would force the water away 11 miles and 360 feet high to Warsaw.
Wow. David, what are all these control panels? It looks like something of a Jules Verne machine here.
It certainly does, doesn't it? Yeah. So this is the actual driving platform. This is where the engine drive would start the engine. And basically, what you've actually got is a main steam valve to start it to work, and then you've got a various combinations of an inlet valve, an equilibrium valve, and an exhaust valve. And the engine had to actually go through a very sort of strict sequence of operation. So it had to inlet steam at the top, open the exhaust valve.
Yeah.
Once it reached the bottom of the stroke, the equilibrium valves would all open. So it was sort of quite a complicated stroke.
And what's the bird bath at the bottom here? This thing.
Okay, so this actually is the control for the cataract. So this is what controls the timing of the engine.
Okay.
So when we talk about the engine operated between 4 and 8 strokes a minute, this little device here dictated that, and it was actually basically a water clock.
Okay.
So it's operating with water. Every time the engine stroked, so a piston got pushed down, and it slowly refilled itself with water.
Like an egg timer made out of water.
Sorry?
Like an egg timer made out of water.
Like an egg timer made with water. So when it goes to temperature, it then releases the lever there, and that enabled the engine to go through another cycle.
Fantastic.
So the engine would do one cycle at a time.
Excellent. Now what we have here is the main cylinder case, which we were doing the chat in front of. So we're going to go upstairs and have a look at the upper section.
Okay, so we're now standing on what we call the cylinder loft. 65-inch diameter cylinder. So if you think about your car cylinder's probably about 2 inches.
Yeah.
So it's got a 65-inch cylinder. In the background are the 3 main valves. We've got the inlet valve, the equilibrium valve, and the governor. And then this little device over here, this is the lubricant that kept the inside of the engine all lubricated. It's quite a delicate little device.
And coming out of the middle of this casing, then this is the main power rod going up to the top.
That's right. Yeah. So that's the main piston rod. That's connected to the main beam, and it's also connected to these James Watt parallel motions. It was certainly impressive when all this whole thing would move and come indoors in about 1.7 seconds.
Yeah.
You certainly felt the wind off it. I think particularly when there's probably 60 tons of moving mass.
So where else can you find a machine of this kind of size?
There's a couple of them that are quite rare. There's a couple of them scattered around the country. One which is fairly local is on the Cromford Canal at Leewood Pump House.
Yeah.
And they have that operating about 4 or 5 times a year. It's not quite as big as this, but it works. And it operates. There's one at Leewood Cromford. There's also a couple down in London. A place called Cubridge, they call it the Museum of Water and Steam. So a couple of engines there that they are operating, and that's about it really. I can't think of any other sort of, there's a couple of waterworks where they've got rotative engines. You've got Burton-on-Trent Claymore's pumping station. They've got 4 engines that run. You've got a couple in Leicester in Abbey Park. They've got 4 engines that run. And there's a very sort of pretty looking engine in Nottingham at Papplewick.
Right.
And again, they've got a pair of rotative engines that also run. And again, that was a waterworks.
So now we're going up onto the top level, which takes us up to the beam itself.
Okay, so this is the main beam loft, as it's called. It contains the beam, hence the term beam engine. I think this beam weighs over 22 tonnes. It was brought here from Tipton with a horse and cart, pulled in through the window, handballed in, as they say.
Oh, awesome. So ultimately it was just sat here. Is it just luck that it survived, or is it a planned?
Sandfields, they did plan to preserve it, but they weren't sort of really sure about what they wanted to actually sort of do in terms of opening up a steam museum. And then a bit of a sort of chain of events took place where the land was then sold,
Right.
and it was bought by a developer. And the problem is, the developer had the same sort of problem. It wanted to build some houses, which it did, but it sort of didn't really know what to do with this.
Right.
Fortunately, a group of local residents realised the historical significance of the place, and so they started a little bit of a campaign.
Yeah.
And sort of says, look, this is part of our heritage. We want it preserving. And so I was fortunate, I was invited to sort of have a look at this and set up a recognised, a registered charity. And what we do, we've now got a group of volunteers who sort of work out every Friday and other days, and they're quite busily sort of restoring it now. And we'd like to sort of bring the thing back to working order.
Yeah.
So we could actually sort of demonstrate it.
Yes.
Because, one of the things about these engines is to tell you how it works is very complicated, but to watch them work,
Yes.
it's a bit of sort of poetry in motion.
Yeah.
They just look so lovely.
Yeah.
And I think the best way to explain it is to actually show people how it works.
That would be fantastic to see.
Yeah.
But the plans go beyond just a moving steam engine, I believe.
Oh, absolutely, that's right. I mean, what we'd like to do is we'd like to sort of engage the whole community in the project. Traditionally, people apply for these huge heritage lottery grants, and a team of contractors come and do all the work and
Yeah.
they go away. What we want to do is we want to give people, first of all, people the opportunity to learn new skills.
Yeah.
So we're doing most of the restoration work ourselves. So we have work parties where there are lots of jobs that can be done, which is repairing the engine. We've got a vast archive of written documentation
Yeah.
that came with the engine. That all needs to be sort of sorted. That needs to be disseminated and looked after. There's general sort of building works. We've got to rewire the place, so we're using apprentices from Dudley and Walsall College
Yeah.
who are going to be sort of doing the work. That gives them the opportunity to do work. And then, of course, in the adjacent building next door, which we can look at later, it's a beautiful open space. It would make an ideal theatre, a cinema, a community space. We've got plans to put a community cafe in there.
Right.
And again, all this is going to be done by the community, so we get this really high level of community engagement where people can take ownership in it and also sort of feel part of the scheme. And I think what we've got to do is we've got to perhaps remind ourselves, what the Victorians did is they built a system, a scheme that was there to serve the public.
Yeah.
And I think we've got to carry that on. So this building, whatever we do to it,
Still
has
serves the
got
public.
to keep serving the public. And as a community, the one thing we do as individuals is when we come together
Yeah.
and when we work together
Yes.
and when we support each other, this building gives us all those opportunities to do stuff like that.
Well, as much as seeing the mechanics of this place, which is awe-inspiring anyhow, that's exciting, but actually to think that you can bring it to life as the backdrop for a community venue
Absolutely.
run by the community for
Yeah.
the community,
Yeah.
that's really quite exciting.
And it is, isn't it? And I think the other thing is, there's tens of thousands of people died in those cholera epidemics in the Black Country.
Yeah.
And a lot of those people were buried in mass graves
Right.
in very sort of poor conditions. And there's no monument to their lives at all.
No.
And so by restoring this building, what that does is some of the projects, with some of the projects we've got planned here, that will enable future generations to actually give those people in the Black Country who died, it will give them back a voice.
Right.
So they can tell the story of their lives as well.
So if people want to see more about this, whereabouts can they find it? No doubt it's on the internet
So
somewhere.
we've got a website, Lichfield Waterworks Trust. We've
Yeah.
got a Facebook page, which is called Lichfield Waterworks Trust. This place is known as Sandfields Pumping Station, so
Yeah.
I think there's another Facebook page called Sandfields
Right.
Pumping Station. And there's now lots of material out on the internet. Just look us up, or actually come and pop in and have a look. Yeah.
Brilliant. Look, thank you so much for introducing this place to me. I really enjoyed my morning here, and I'll wait to see all the comments that come on the video. So,
Yeah, well, thank you too, Andy. It's been great talking to you.
thank you very
Real
much.
pleasure.
Well, I hope you enjoyed that insight into the life and times of the Sandfields Pumping Station. It had a profound impact on saving the Black Country from cholera back in the late 1800s. And even today, it's being refashioned and repurposed so that it can be used by the local community for the local community. go and onto their websites, have a look, see how you can get involved. Anyhow, in my next episode I'll be following the line of the Ogley Locks through from the Birmingham Road, and over the course of 2 episodes we're going to explore it all the way down to Huddlesford. But a bit of a spoiler, it's not all abandoned canals. This one is highly active in renovation, so you'll find lots of evidence of restoration. Anyhow, till then, hope you enjoyed the episode and I'll see you soon. Bye.